All right, lesson 10.4 is an introduction to probability. If you'll remember back a couple of years ago in 7th, 8th grade math when you were working on probability, remember probability is just the chance that something will happen. So real quick, there's a couple terms that I wanted to go over with you. A couple of those being and, or, and not. I know this is going to sound like an English lesson, but remember, and, if you use and in the phrase, then and has to be satisfied in both. It has to be in both of them. So like if we wanted to do a Venn diagram, this part of the circle right here is included in this part of the circle. So whatever would fit in this area right here is considered the and, because it's in both circles. Okay. When you refer to or just means that it has to be in at least one. So the and means it has to be in both. Okay. So and means it has to be in both. Or means it has to be in at least one. Has to be in at least one of them. Okay. And not would be everything that's included everywhere else. So like if I was including everything that's not in, like if this was circle A, and then this was circle B. Then if I wanted everything that wasn't in circle B, then it would include everything in A, basically. But it would include also this, even though this part here is in A, it's also a part of B. So we have to not include that also. So, all right, so let's cover a basic definition of probability. Probability is the possibility an event will occur. Okay? Now typically probability is going to be expressed as a fraction. So it's going to be written as a fraction. In some cases it can be expressed as a decimal. Or it can be expressed as a percent. Okay, those are two occasions where you can have probability. If you have a probability of exactly 1, that is a guarantee it will happen. So whatever your event is, it's the probability the event will happen. If you have a probability of 0, that means it will not happen. Okay, and that halfway mark, the halfway, you have it's a good chance it will or it won't. It could go either way. Okay, so a low probability would be anything that is less than a half, but not past 0. And a good probability would be anything that's greater than a half, but not over 1. If you go over 1, then you've got a mistake, because probabilities, the maximum they can be is 1. Okay, and the way you find probability is, first of all, when you write your fraction, it's the total outcomes. Let's put outcomes in there. It's the total outcomes over on the bottom, and on top of that, then we're going to put the possible outcomes. So in other words, when you're looking at this, if I wanted like the probability of getting tails, well, there's only one tail, so the probability of tails, there's only one tail. But there are two possible outcomes, because the coin can get either heads or it can get tails. Okay, so let's take a look at a quick example. First example says you roll a 6-sided die whose sides are numbered 1 through 6. Find the probability of rolling a 4. So we've got this one die, and it's got the numbers on it 3, 4, 5, and 6. Okay. So we want to know, what is the probability of rolling a 4? Well, remember, our total outcome is 1, 2, 3, 4, 5, 6. We have 6 different outcomes that can occur. How many of those are a 4? And if you look at it, we only have one of them that's a 4. So our answer in this case would be 1/6. Okay. B, what's the probability of rolling an odd number? Well, all you got to do is count the odd numbers. The only odd ones would be 1, 3, and 5. So we have 3 possibilities out of a total of 6. Make sure you reduce it, and our final answer is 1/2. Okay. Number 6, what is the C? What is the probability of rolling a number that is less than 7? Well, if you look at these, they're all less than 7. So our possible outcome is 6 out of 6. So there's an example of a probability of 1 and a guarantee that the event will happen. Okay? All right. Example number 2. It says a spinner has 8 equal sectors numbered 1 through 8. Find the probability of spinning a 6. So we have this spinner, basically, and it's numbered 1, 2, 3, 4, 5, 6, 7, and 8. And we want to know what's the probability of spinning a 6. Well, if you look at it, there's only one place on there where there's a 6. So I have a 1 out of, and I have 8 different outcomes. Okay? So it'd be 1/8. Okay? On part B, I want to know what is the probability of spinning a number that is greater than 5. Well, 5 is not greater than 5. It's equal to 5. So we're going to count 6, 7, 8. So I have 3. And again, I have a total of 3 8s. 8. Okay? So the answer would be 3 8s. Okay? Now, there are some called experimental probabilities, and that's basically if we give you a variety of information, say in the form of a bar graph. So this is in 1998, a survey asked internet users for their ages. The results are shown in the bar graph. What's the probability that the internet users were at most 20 years old? So we want to make sure that they were at most 20 years old. Okay? So in other words, we're not going to include anybody that's 21 because they're over 20 years of old. So anybody under 21. So I have 1,636 people in the survey that were under 21. Now to get our total, because our total is, we've got 1,636 under 21. 21 to 40 years old was 6,617. 41 to 60 was 3,693. 61 to 80 was 491. And the ones over 80 were 6. So what you actually need to do is, when we're looking at this, we need to find out how many total users were included in this survey. So simply all we're going to do, because remember probability is the possible outcomes over the total. So we're going to add them up, 1636 plus 1636 plus 6,617 plus 3693 plus 491 plus 6, and we get a grand total of 12,443. Now, this is a good example of, these are some pretty ugly numbers, and so to get an idea, is this a good probability or a bad probability, let's go ahead and divide the 1636 divided by 12,443. And we find out that we get 0.131. Okay? So that's a really low probability if that we would select somebody that's at most 20 years old. Okay? All right. So question number B says, what is the probability that the internet user was at least 41 years old? So if you look at this, well, we've got these people here that are 41 years old. So we've got 3,693 that are at least 41 years old. So when you're looking at it, is that the only group that is at least 41 years old? And you quickly find, no, wait a minute, because these 61 to 80s are also at least 41 years old. And then you also have to include the people that are over 80. And all we're going to do is we're going to add those to get what our actual answer is. 3693 plus 491 plus 6 gives me 4,190 all over 12,443. Okay? And since these are kind of some ugly numbers, we're going to go ahead and divide those out. And we find out that we get 0.337. Okay? All right, so in the next example, I want you to go ahead and do this one as a you try. So go ahead and pause the video. And then go ahead and restart it, and we'll work your way through it. All right. In this one, it says the ninth graders must enroll in one math class. The enrollments of ninth grade students during the previous year are shown in the bar graph. Find the probability that a randomly chosen student from this year's 9th grade class is enrolled in. So we want to pick consumer math. Well, if we look consumer math, we have 36 students. And just like the last one, we need to find out how many total students were included in this survey. So we have, if we look at this, in Algebra 1, we have 87. In consumer math, we have 36. In geometry, we have 69. And in the introduction to algebra class, we have 51. So we have a grand total of 243. Okay? And that's a good one to go ahead and divide. 36 divided by 243 gives us 0.148. And make sure you're rounding your answers appropriately. All right, in B, it says Algebra 1 or the Introduction to Algebra. So the same thing on before, we have 87 students that are in Algebra 1. And in the Introduction to Algebra class, we have 51. So to get how many total students are in either one of those classes, we're just going to add them up. And we get, 87 plus 51 gives us the total of 138 out of 243. So 138 divided by 243 gives me a grand total of 0.56. And remember, we got to round that to an 8. So 0.568. And since it's over that half, that's a high probability that we will pick somebody that's either in Algebra 1 or in the Introduction to Algebra class. Okay. Now there is one key point here. Remember the first slide that we talked about, the and versus the or? Whenever you see an or, and this is what we're gonna actually get into in the next 2 lessons. But when you see the word or, that's going to give you a clue that we actually need to add. Okay. All right. So let's go ahead and take a look at a couple more last examples that we wanted to cover real quick. It says a jar contains 5 red marbles, 3 green marbles, 2 yellow marbles, and 1 blue marble. Find the probability of randomly drawing the given type of marble. So part A is we want to find a yellow marble. So first of all, we got to find out how many marbles we got. We got 5 red, 3 green, 2 yellow, and 1 blue. So if we find the probability, we have 2 yellow, and we add them up real quick. 5 and 3 gives us 8. 2 more gives us 10. 1 more gives us 11. So we have a 2 out of 11 chance of getting a yellow marble. And the last one, a green or a yellow marble. There's that word or again. So we have 3 green and we have 2 yellow. So we have to add those up to get a grand total of 5 out of 11. Okay. Now, a lot of times, and the only reason I wanted to show this last example real quick is because you've got to be really, really careful when solving these questions, because it says your cousin lives on a small farm. She is a member of the 4-H club and is showing 9 animals at the county fair. 2 of her animals won blue ribbon, 1 animal won red ribbon, and 3 won white ribbons. You don't know which animals won the prize. You choose one of your cousin's animals at random. What is the probability that the animal won first place? So if you remember, first place is going to be the blue ribbon. So I want to know, what's the probability that they got a blue ribbon? Well, 2 of her animals won first place. But the question is now, how many total animals? Well, we had 2 that won blue, 1 that won red, and we had 3 that won white ribbon. So if you add just those up, 3 plus 2 gives us 5, 1 more gives us 6. But the probability is not 2 out of 6, because you've got to read the questions very carefully, because a lot of times they will give you the total. And we missed out the other information. She took 9 animals to the fair. So in this case, the answer would be 2 out of 9. So if we had 6 animals that won a prize, we had 3 animals, unfortunately, that didn't win anything. Okay? So just as a quick recap, remember that probability, 2 things that we really are important in this lesson is, 1, probability. When you're finding probability, it is the possible outcomes over the total outcomes. And the last thing is, whenever you see the words or, you're going to have to remember to add. Okay? So those are the 2 most important things out of this lesson.